Hello students, in this video we shall study about the bond lengths in molecules. We can say that how to compare two bond lengths. First of all, we will see that what is bond length. Bond length is the distance, it is the distance between two nuclei of bonding atoms. For example, if we look at the example of water molecule, then we see that this is oxygen and it is hydrogen atom. This is oxygen and this is hydrogen atom. This is H2O, and this length, this is bond length of OH bond. So this is the how to see that what is the bond length and how can we compare the two bond lengths. So there are some rules, and let us see what are these rules. After studying these rules, you can compare the bond lengths in the molecules, and the rule number 1 is size of bonded atom. See, if the size, atomic radius of bonding atom is more, then you see that bond length will be more. How? See, there are some molecules like HF and then HCl, then HBr and HI. These are 4 molecules. Let us compare the bond lengths of these molecules. See, fluorine is the fluorine, chlorine, bromine and iodine. In these molecules, the other atom is same, hydrogen, but the fluorine atom, size of fluorine is less than chlorine, and chlorine size of atom of chlorine is less than that of bromine, and bromine is less than iodine. It means that iodine is the largest atom in these 4 atoms. So Hi bond length will be more. Then it will, the order of the bond length will be Hi greater than HBr, greater than HCl and greater than HF, because the atomic radius of iodine is more than that of bromine and that of chlorine and that of fluorine. So HF bond length is 92 picometer, or we say 0.92 angstrom. Here it is 127 picometer, and in HBr the bond length is 141 picometer, and in HI the bond length is 160 picometer. So HI is the bond length in HI is largest. Now this is the rule number 1, which is we say that size of the bond length depends on size of the bonded atoms. If atomic radius of the bonded atom is more, then bond length will be more. Now the second rule. Second rule is hybridization. See, in this rule we say that higher the S character, then less will be the bond length. S character यदि ज़्यादा, if higher is the S character, then bond length will be less. In this way, we say that in sp3 hybridization, the S character is less than in sp2 hybridization, and it is less than sp hybridization. It is S character, because in sp3 p has more weightage than s orbital. So in this way, we say that bond length of sp3 will be more than sp2, and it will be more than sp. Why s character orbital of s orbital is spherical shape and p is dumbbell shape? So length of p orbital is more than length of s orbital. So higher the s orbital, s character in the hybridization, then lower will be the length of the bond length. So in this way, we say that, let us compare these. See, H3C, CH3, CH2, sorry, H2C, CH2, and HC, CH. Here it is sp hybridization, here it is sp2 hybridization, and here it is sp3 hybridization. So if we see that this bond length is 153 picometer, and CH in this sp2 hybridization, this is 133 picometer, and sp hybridization, this is. So we see that in sp hybridization, the bond length is the least, because s character of orbital is in hybridized orbital is most in sp hybridization. So bond length is least, and here sp3, here s character is less, p character is more, then hence the bond length is more here. So this is rule number 2, and this is known as hybridization versus bond length. Okay, now we come to rule number 3. Rule number 3 is bond order versus bond length. How these two things are related? See, higher the bond order, less will be the bond length. Bond order increases, then bond length decreases. See, in this example, this is first order. Here order is 1. Here double bond order is 2. Here triple bond order is 3. So here the it is 118 picometer, and here it is 133 picometer bond length, and here it is 153 picometer. So where the bond order is least, then the bond length is highest. So this is the rule number 3, bond order versus bond length, how the bond length is related to bond order. Now we come on to rule number 4. Rule number 4 is the resonance structures. Higher the resonance structures, less will be the bond length. Bond length decreases. So we compare see, this is CCl bond length in CH3 CH2 Cl. This is the, or we can say, we can write it this way, H3C H2C Cl. This is the first molecule, and second molecule is H2C CH Cl, and third is chlorobenzene. See, these are 3 molecules. Now we are to compare CCl bond length. Here there is no resonance. Here it is no resonance. Here there is double bond and lone pair, then lone pair and double bond. Presence of lone pair, double bond and sigma bonding, then we say that there is resonance. So double bond can be interchanged here to here, and we say there are 2 resonance structures of this molecule. And in this case there are 5 resonance structures. How? See, here it is a lone pair, the lone pair on Cl, then it is, if it is, this is the another resonance structure. This way and then here it is this, then here again so these are A1, 2, 3, 4, 5. 5 resonance structures here, and negative charge going on this way. So 5 resonance structures. So where there is resonance structures are more, then what happens? The bond has partial double bond. Partial double bond. So the bond length is less. If there is double bond, then bond length will be less. So in the third has the, in case bond length of 1 is more than 2 and it is more than 3, because in resonance it is no 0 resonance, here 2 and here 5. So which has most resonance structures, then the bond length will be least. Now we come to rule number 5. Rule number 5 of bond length. In this rule, it is bridge bond length. The bond length of the bridge bond is more than terminal bond length. How? See, this is the molecule and one CH3 this is the molecule. Then in this molecule we say that if this is X and this is Y, then we will say that bridge bond length, this is bridge bond length because it is the bridge between the two ligands, two groups, it is the bridge, and this bridge bond length X is greater than terminal bond length Y. So this is rule number 5. Now we come to in many exams it is asked this way, the question is asked this way, which bond length is, compare these two bond lengths. So the rule will be the bridge bond length is greater than terminal bond length. Now we come to rule number 6. Rule number 6 is all bond lengths are equal if all the atoms of molecule are in same plane, and bond angles are same. Means the geometry of the molecule is regular. Look, here it is XeF4. This is the example of the molecule. Here it is scale planar with all the bond angles are 90 degree. It is Xe, then F, F, F and F. These are scale planar molecule with all the angles are 90 degree. Then we say that all the bond lengths are equal. This is the rule number 6. So this way we have seen that how can we. Now we come to rule number 7. Rule number 7 is, for the bond length, is that if there is presence of lone pair, so lone pair has more S character. Then what happens? The other bonds in the molecules, has less S character. When they have less S character, then their bond length will be more. See how? We have example here. This is S, F, 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 and here it is a lone pair. And another molecule is S, O, F, 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 F. Then we have to compare. Here it is, see, let us, the bond length of in SF in this molecule is X, and in this molecule SF bond length is Y. Then we can compare X and Y. How? This lone pair, in this lone pair, it has more S character. Then this bond will have less S character and more of the P character. Hence, this X will be more. But here there is no lone pair, and this bond length will have more S character. So Y will be less. X is more, and then Y. Why? Because lone pair has more S character. Then the other bonding orbitals, they will have less S character. So X will be more. So other bonds have less S character. So bond length is more. In this way, we can we are having these 7 rules for comparing bond lengths, and I hope that any question on bond length, comparison of bond lengths in two molecules, you can do these questions.